Hi, Layla. Um, I'm glad you texted me about this question from homework. I believe this is homework 6.4 in your class about doing what's called function decomposition. I intentionally did not make a video over this because I wanted people to encounter a situation that involves the material that we talked about, but not necessarily in a specific way. In this example, we're reverse engineering a function composition. In previous videos or in previous homework problems, you were given two functions, f and g. You were given two functions, f and g, and asked to do this to them to create a new function called h of x, or whatever the new function was called. But here, we're given the result of the composition, and we're asked what two functions can we compose to get that. Now, there is a trick to doing this. The trick is to literally reverse engineer the process. We're trying to figure out an f and a g, f of g of x, that ends up being the absolute value of 8 minus 5x squared. Well, let's send this backwards for a second. We'll go back and forth and we'll see what happens. All right. So we want f of g of x, which is the definition of f of g of x. And when we're doing this, the first move that we do is replace the inner function with what it equals. Now, we don't know what that is yet. So we'll just open up something and we'll put a blue line underneath here. Now, when we do a function on a function or a function on an expression, you may have recalled in that last video that I did a little something like this, where I said, all right, we're going to take this and we're going to put it into the next function. Well, that kind of shows that whatever was in here might have been the 8 minus 5x squared. So let's reverse engineer this and write 8 minus 5x squared there. Now, if we did, what we just did is say that, I'm getting something ready here, g of x is equal to 8 minus 5x squared. Okay, but what about the f? Well, if we call g of x this, and then we put it into the f function, then we put that guy right there. Right where? Right inside the absolute value. So the part that isn't highlighted in yellow, and I'm going to do another yellow highlight over here, the part that isn't highlighted in yellow represents what my f function does. Well, what did my f function do to the part highlighted in yellow? It put it inside of an absolute value. And which function says f takes the absolute value of something? That would be this one. So it seems like if we have f of x equals the absolute value of x, and g of x is equal to 8 minus 5x squared, then f of g of x should give us h of x. We could always check it by doing the problem moving forward. F of x equals the absolute value of x. G of x equals 8 minus 5x squared. And if we find f of g of x, by definition, that's f of g of x. I wish all this was in red, but that's okay. We start with the inside function and replace it with what it equals. Well, g of x is equal to 8 minus 5x squared. And now we do what f of x does. Well, f says, give me something and I'll take the absolute value of it. But what am I giving the f? This. So this goes inside of there. And we end up with the absolute value of 8 minus 5x squared, which ends up being h of x. This whole concept of function decomposition is previewing a skill that is critical in calculus. And I know maybe you are or are not going towards calculus, and the same goes for anybody else who's watching this college algebra video, but you and every single person in your class are on a path that calculus students take en route to calculus. So whether or not you'll get there is a different story. So a lot of times these supplemental skills at the end of homework assignments are previewing how this topic gets used in higher up math classes. I do want to point out one more thing, that this is not the only possible way to decompose this. Given the functions that I was given, those would be the ones that I choose. But Layla, I know you are really on top of your game, and anybody else who is watching this, I just want to show you that there is more than one way to decompose a function. We're going to take this function, and here I am pushing the envelope a little bit more, and I am going to reverse engineer it the same way I did before. Right, f of g of x equals f of g of x equals f of something. And then we want the absolute value of 8 minus 5x squared to be the final result. Well, when I reversed engineered this a minute ago, I said whatever this was, what if we would just dropped it inside the absolute value? But what if whatever was in here just landed right there? If I can widen this a little bit, there we go. What if whatever was inside the f function landed where the yellow is? Well, the yellow is on 5x squared. So if that's what got stuck over here, then that means g of x would have been 5x squared. But what would f of x have equaled? Well, if we get rid of this and where it went, then we kind of see the skeletal structure of what f would do in this case. And we can see it more clearly by saying, let me put an x here and an x here. So it looks like f of x equals the absolute value of 8 minus x would get the job done as well. I'm going to restore this back to the way it was because I just want it to look right. This was 5x squared. This was 8 minus 5x squared. So there's multiple ways to decompose a function into the composition of two other functions. But again, given the answer choices I had here, the only way we could have done f of g of x was if f of x was the absolute value of x and g of x was 8 minus 5 squared. And I'm going to push this envelope one step further. Some functions you can actually decompose verbally. Here's how. By asking yourself, if I put a number inside of here, what would happen to it? Well, in order, what would happen to a number that gets put inside of here? First, it would get squared. Then it would get times 5. Then you would subtract from 8. Then you would take the absolute value. So here's a real sneaky way to do a function decomposition. If you can describe your function as a sequence of do this, do this, do this, do this, and there are functions where you cannot do that. All you have to do if you can describe the function as a sequence of steps is cut them off somewhere, like here, make the first one G, make the second one F. Well, if G did this, G would take a number, square it, multiply it by 5, and then subtract it from 8. What does F do to a number? Take the absolute value. But that's if I split it right there. If I had split it right here and called this G, because it happens first and then F, then G would take a number, square it, multiply it by 5. F takes a number, subtracts it from 8, and takes the absolute value. Or what if we made the split here and called this G and called all these F? Then G would square a number. G says, give me a number and I'll square it. F says, give me a number. I'll multiply it by 5. I'll subtract that from 8, and I'll take the absolute value. So you can think of a decomposition as, hey, here's a sequence of steps. We're going to call the first few steps G, the second one F. This is probably a lot more than you were expecting, but by now you should know that I like to raise the bar when I can.